Have you ever wondered how a computer program goes from just dumbly following a list of instructions to, well, to actually making what feels like a smart choice? It's not some kind of magic. It's all about logic. And over the next few minutes, we're going to build that logic from the ground up and really see how programs think.
So yeah, this is the big question, right? And to answer it, we're not just going to sit here and talk theory. Now, we're going to get our hands dirty. We're going to build a simple program and give it the power to choose, one step at a time.
To make this all feel really concrete, we're going to build something we've all used a million times, a simple password checker. It seems basic, but this one little task is going to show us the absolute fundamental building blocks that control how pretty much every single program runs.
Okay, so at the very heart of any decision a program makes is something called Boolean logic. And it's actually super simple. It's a world where there's no maybe, no kinda. Every single question the program asks itself has to boil down to one of two possible answers, true or false. That's it.
So, how do we ask those questions? We use these things called comparison operators. Now, the double equal sign is absolutely crucial. It's not saying make this equal to that, it's asking a question. Hey, is the user's input the same as the word secret? And the one with the exclamation point just asks the opposite. Is it not the same? This is how we get our true or false answer.
But, decisions are rarely based on just one thing. What if you need to check multiple conditions at once? Well, we can use logical operators like AND. This lets the program check several things at the same time. And with AND, the whole statement only becomes true if every single part of it is true. This is how you start to combine simple rules to create some really complex logic.
Okay, so now we have our true or false answer. So what? The program needs to actually do something based on that answer. And this is where conditional execution comes in, the code that literally lets a program choose which path to go down. And this is the if, elif, and else structure in action. It's like a waterfall of logic. The program checks that first if condition. If it's true, boom, it runs that block of code and it's done. It doesn't look any further. But if it's false, it moves on to the elif, which is just short for else if, and it tests that next condition. And if none of those are true, it just falls through to the final else block. It's a really clean, cascading way to make a decision.
So, bringing this back to our password checker, it's a perfect fit. If our password comparison comes back as true, we grant access. Else, meaning in every single other case, we deny it. Just like that, with this simple little structure, our program can now make a decision.
But hold on a second. Our program is still kind of dumb. It only asks once. What if someone just makes a typo? We really need a way to repeat the action of asking for the password, and that introduces a whole new challenge for us: repetition.
Now, in programming, we have two main tools for repetition. A for loop is great for when you know exactly how many times you need to do something, like go through all 10 items in this list. But for our password checker, we have no idea how many tries the user's going to need, right? This is the absolute perfect job for a while loop.
A while loop is so powerful because it can repeat indefinitely. It's all governed by a single condition. And as long as that condition stays true, the code inside that loop will just keep on running over and over again. So for our program, the logic is really simple. While the password is not correct, just keep asking.
Now, that power to repeat forever is also a bit of a trap. If that condition never becomes false, the program gets stuck in what we call an infinite loop. It just runs forever and never stops. That's why we need some specific tools to control our loops and, when we need to, escape from them.
We've got two main tools for this. Continue is useful. It basically says, okay, I'm done with this round. Skip to the top and start the next one. But break is our emergency exit. It just terminates the loop instantly, no questions asked. For our password checker, when the user finally gets it right, break is exactly what we need to just stop asking and move on.
Okay, let's watch this whole thing in action. The while loop starts. Attempt 1, user gets it wrong, so the loop continues. Same thing for attempts 2. But on attempt 3, they finally type secret. Our if condition inside the loop becomes true. That break command gets triggered, and bam, we're out of the loop. Success.
All right, so let's just step back for a second. We went from a really simple question to a piece of code that actually works, and we did it by combining just a few simple but really powerful ideas.
See how each of these concepts just builds on the last one? It's like Lego bricks. We started with a Boolean to get it true or false. We used an if-else statement to act on that answer. We wrapped that whole thing in a while loop so we could do it again and again, and then finally we used break to give ourselves a clean way out. Every single piece has a crucial role to play.
And honestly, this is the most important thing to take away. Yeah, we just built a tiny password checker. But the logic that powers a self-driving car, or the algorithm that builds your social media feed, it's built from these exact same fundamental blocks: Booleans, conditionals, and loops, just stacked together on a mind-boggling scale. So, knowing that, what kind of complex logic could you build